Progress.
Hello all. In today's session, we are going to study about what is overfitting and what is underfitting in machine learning. Overfitting and underfitting in machine learning. Very important concept. So we know that we do have a machine learning model, ML model with us. So for this ML model actually takes some data, and based on the data, it makes some predictions. These predictions further can be sometimes, we can say that accurate, this can be accurate, or sometimes not that much accurate. So we will call it as inaccurate. So when we talk about a good machine learning model, good ML model, so we want accurate predictions. The model which is providing us inaccurate prediction, we are never interested into such models. This overfitting and underfitting concept actually deals with the accuracy of the model. It deals with the accuracy of the model. So sometimes during the training of the model, some inaccurate results or your model does not get that much trained, which may result into producing inaccurate results, and that may introduce some sort of errors into the performance of the model. So we are going to focus on that concept by using the concept or using the terms of underfitting and overfitting. So normally when we train any model, we do have some data set with us. We do have some data set with us. So in our earlier discussions, we said that we divide data set into two subparts. First one is called as training data set and another is called as testing data set. When we train any ML model, so that time we provide training data set for training the model, and that gives us some results. Let us say that we are getting the accuracy something like 85% or 90% or something like that after training the model. So once the model gets trained, we give testing data to that particular model, and we check the accuracy of the model, the same ML model, and we check the accuracy of that model. If that accuracy we get it like 80% or 92%, something like that, so we can say that this model is performing good. But what happens if we get accuracy something different? So if we are getting the accuracy, suppose this is what my ML model, we can say this is what my ML model, and we have provided some training to that ML model using the training data set, and we got accuracy something, we can say that 92% accuracy we got. This is what the accuracy in the results predictions we can say. And when we test the model based on the test data set, so if we test the model, same model on the test data set, and if we are getting accuracy equal to suppose 70%, so there is a lot of gap between this 92% and 70% accuracy. We can say that it is around 22% gap. So this time we can say that the model which has performed good on the training data set is not performing well on the testing data set. So performance is getting down over here. So here normally in case of overfitting what happens? I will tell you in short now. In the concept of overfitting, when we train the model based on training data set, when we are training the model based on training data set, we can say that we get very good accuracy. But when we test the model using testing data set, our accuracy goes down. Our accuracy goes down. So this concept is called as overfitting. This concept is called as overfitting. So what is happening in overfitting? We do have training data set also. We do have testing data set also. But when we train the model using training data set, our accuracy, we may get accuracy good. Let us say that 95% or 99%, whatever. But when we test our model based on the testing data set, which was unknown at the time of training, this is suppose new data set and we are testing our model based on the testing data set, our accuracy is going down. Let us say that 70%. So there is a huge gap between this 70% and 95%. Okay, and that is creating a problem of overfitting. Let us talk in terms of a graph. I will show you one graph for making the concept more clear. So now this is what the graph. Let us say that I do have some data points like this with me. Okay, and we can say that if we can say our model is predicting the values, something like that also something. So if our model is predicting the value and we are getting the curve like this thing, this is my training data set, and we are getting the predictions like this thing, something, the curve is very complex here. Okay, this is what my training data set, all the data points are inside the training data set. So we can say that we will get here 100% accuracy. But if we give some testing data set, likewise, if we can say that if we do have some points like in the testing data set, this is the point, 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 this is the point. So probably in that case our accuracy will go down because your curve will not get fitted into these points. So in this case we may say that our accuracy may go down. So that is the problem of overfitting. In case of overfitting, our training accuracy is very high. Training accuracy is very high. But when we apply the same model on test data or testing data set, so that time our accuracy drastically reduces. The performance of the model reduces. So this problem is called as overfitting problem. Overfitting problem. So then now let us talk about underfitting problem. What is underfitting? Now again, if I'm training a model, machine learning model, I'm training a machine learning model on training data. Train data set is there. And I'm doing some predictions, but the accuracy is, let us say that 60% accuracy I'm getting on the results. Okay, these are the predictions. For on the predictions, we can say that I'm getting 50% accuracy or 60% accuracy, something like that. So my accuracy is very low over here. When I apply test data set on that particular machine model in this situation, probably I will get very bad accuracy here also. I will say that I will get suppose 35% accuracy or 40% accuracy, something like that. So here on the training data, whatever the predictions I am doing, I am getting less accuracy, and for the test data also I am getting less accuracy. So here in underfitting case, we can say that, in short, when if we summarize, we can say that for training data set, when we train the model on the training data set, we are getting less accuracy, and when we test the model based on testing data set, we are getting less accuracy. So both accuracies are less, so that's why the model will not perform in real time scenario properly. So this is the concept of underfitting. So both these concepts are very important in machine learning, from machine learning aspects. So we should know those are both these concepts. So if we take one real-time example of a student who is giving real-time example of a student who is giving examination, real-time example who is giving examination, who is preparing for the examination and then giving the examination. Suppose a student has prepared some course. Let us say that student has prepared a course of Python programming. He has done study as per the notes he got from the teacher. He might have got some notes from the teacher, and based on these notes he might have studied. He has studied very good from that particular notes. He is confident about the things that teacher has taught him. But now the issue is that now we can say that the model is trained based on the notes of the teacher. This is what the training data said. The model is trained. This is what the model. The model is trained and the model is performing very good. It means that the student is performing very good based on the basis of the notes that teacher has given to him. So the performance of the student is very good in that case, very good in that case. But now when the student appear for the exam, so that time the questions, we cannot say that the question will directly come as it is from the notes. Now the testing data set will be different. Probably it will contain the data which is not present in these notes. So in that case, this model's performance may go down, may go down. This model's performance may go down, and if the performance is getting down, we can say that the model was overfitted model. On the training data set, the overfitting was there because the student has done study only from the notes. He has not considered any reference books, he has not considered any textbooks, and so on. So this is the concept of overfitting from the student point of view. Similarly, we can go with the for the concept of underfitting. Okay. Now, what will happen in the underfitting in student's case? That student, suppose that student has studied from the notes, model is trained, model is trained, and it is giving. He has not prepared the notes also properly. So the performance of the student will go down here. Okay, he has not prepared from the notes, so the performance will be not that much satisfactory. It is like less performance. Now when the student, he has not studied the notes, and whenever he will appear for the examination, then on the test data set we can say that the performance of the model will also be not satisfactory. So here both the cases, in while training the model as well as while testing the model, the performance of the student will be not satisfactory. So we can say that this is the case of underfitting. So guys, I hope that you might have got the concept of underfitting and overfitting. Now two more terms are associated with underfitting and overfitting. So that is, first one is called as bias and second thing is called as variance. VRANCE, variance. So these two terms we will talk afterwards in the next video. But just a closing note of this session, if overfitting is there, remember that there will be more variance. And if underfitting is there, we can say that there will be more bias. So in case of overfitting, variance will be more, and in case of underfitting, bias will be more. So I will make one more video for explaining these two concepts. So that's it in this session. Thank you.